Hello, in this part 2 of our Developers Crash Course video, we're going to quickly look at the details behind the configuration file we deployed to run the demonstration scenario presented in part 1. We're trying to keep this brief, so we're hopefully going to flesh out just enough detail to provide a decent overview of how the rule sets are processed by the SoftHub's rule engine. Note though that there are many other videos on our YouTube page and documents in the support section of our website that will provide much fuller detail regarding the configuration process, the configuration utility, the SoftHub rule engine, and the individual rule engine objects that are available to build your applications. Before we look at the rule set that was used, there are a few points to understand about the rule engine and the rules that make up an application. First, the rule engine is object-based. We currently provide a range of roughly 60 different objects the user can draw on to build their rule sets. The rule engine objects fall into 6 general categories. Event objects define events we want the rule engine to monitor for. Action objects carry out the actions we want the rule engine to perform. State objects are used to conditionally control the execution of our rules. Sensor objects define each of the specific sensors we want our hub device to connect with. Report objects allow us to create our own custom packets. And lastly, the rule objects themselves, which as you will see are actually structured references to a set of event, state, and action objects. The structure of a rule object can be thought of as a when, if, do statement. When the rule's triggering event occurs, if any optional state logic is satisfied, we do a list of actions. Now we'll look at the pseudocode for the rules used in the demonstration example, and then afterwards we'll return to the configuration utility to review some representative rule and object definitions from the original configuration file. This table summarizes all of the logic used to create the rule set in our demonstration. Before we start, it is important to understand that the events in the rule set are completely asynchronous. With a few exceptions, any event can happen in any order and at any time. The rules associated with an event, however, will be carried out in the order specified. In the table and in the actual rule set file, events have been grouped only for the sake of readability. For the demonstration scenario, there were 9 events and 14 rules. The 9 events we monitor for fall into 5 categories. The event indicating the SoftHub application is starting, the event indicating the SoftHub application is stopping, the event indicating the button has been pressed and released, a group of events indicating a timer has expired, and another group of events indicating a new packet has arrived from a connected sensor. When the application starts, we initially want our application to be in mode 0, which is to say we're not going to be forwarding any packets we receive, and the LED will be off. So when the app starting event gets written to the rule engine's message queue, we're going to unconditionally execute a single rule that will do 2 things. First, we'll turn the LED off, and then we'll create a counter that will be used to keep track of the current mode for the duration of the application. We'll initialize the counter to 0, and we'll set a modulo of 5 so that as it gets incremented, its value will continually cycle from 0 to 4, reflecting the 5 operation modes we've defined. Similarly, when the app stopping event gets queued, we'll be sure to turn the LED off before exiting since our application will no longer be active. Next, we have the button released event, meaning the user has pressed and now released the input button. We actually have 6 rules that will be processed sequentially when the button released event occurs, but for now we're only going to look at the first rule. That rule will always be executed first, has no conditional logic, and will simply increment the mode counter. This ensures that after every press of the button, the mode counter will immediately reflect the proper current mode. We'll get back to the remaining button released event rules in a minute, but first we'll look at the next group of events we're monitoring for. We have 3 new packet events we'll be monitoring for, 1 for each sensor. When any of these events gets queued, we'll check the state of the mode counter to see if it's either in the Send All Packets mode, which is mode 1, or if the mode matches the mode to send the specific sensor's packets associated with the triggering event. If either of these conditions are true, we'll send the latest packets received from that sensor to our remote packet capture server. With only the logic we've described so far, we're able to properly forward our packets to our remote server. All the remaining logic we'll look at is only to control the LED to correctly reflect our current mode. Before getting into that logic, we'll talk about one of the SoftHub's most commonly used and most powerful action object types, the timer object. The SoftHub provides a variety of timer object types, but for this example we used a set of 3 continuous timers. Continuous timers will run until their timer value elapses, write their timer expired event to the rule engine's message queue, and then immediately restart themselves. They will continue like that indefinitely until explicitly stopped. For the demo we created 3 timers, a slow timer for slow blinking the LED, a medium timer for blinking at a medium speed, and a fast timer for fast blinking the LED. That brings us to the next group of events we're monitoring for, the expiration of an LED blink timer. These rules have no conditional logic since, as you will see shortly, each timer is only active when its associated mode is currently selected. The only action to perform when one of these timers has expired is to toggle the value of the LED, causing it to blink. Going back to the remaining button release rules we haven't yet covered, after the first rule has been executed updating our mode counter, we'll execute only the one rule in the remaining list appropriate to transition our LED to reflect our new mode. This is ensured due to the mutual exclusivity of the conditional logic for the remaining rules. So very quickly, starting with the first button pressed to transition from mode 0 to mode 1, we'll only turn the LED on. To transition from mode 1 to mode 2, we start our slow timer. To transition from mode 2 to mode 3, we'll stop the slow timer and start the medium timer. To transition from mode 3 to mode 4, we'll stop the medium timer and start the fast timer. And lastly, to transition from mode 4 back to mode 0, we'll stop the fast timer and turn off the LED. And that summarizes the 9 events and 14 rules it took to configure our demonstration scenario. Now let's take a look at the configuration file again and some representative objects from our rule set. Looking at the single rule associated with the app starting event, we see the triggering event, that there is no conditional state logic, and that there are 2 action objects that will be executed. The first of the 2 is an initialized counter action object we'd previously created and named doInit mode indicator. We set its initial value to 0 and its modulo to 5. Note that the context-sensitive help screen to the right will provide details regarding the current object's function and each of its parameters. The second action object from our rule is a setGPIO pin low action object that we'd named doSetLEDOff. We selected GPIO pin 17 from the drop-down list of output pins we'd enabled in the GPIOs section of the Global Systems options. So again, when the system startup event occurs, we execute our 2 action objects in sequence to create our mode counter and to turn off the GPIO pin connected to the LED. We'll look at one more rule, which is the rule that gets evaluated whenever a new packet arrives from the Thingy52. Though the rule doesn't reference it directly, we're going to start by looking at the sensor stream object definition for the Thingy52. When creating a new sensor stream object, you right-click on the Sensors node and select New, and then you select the type of sensor you want to add, an ANT or Bluetooth Low Energy sensor, and then you select the specific sensor type from the drop-down list of supported sensors. This will expose a list of all sensor stream values the sensor can broadcast. You can use the list to multi-select the set of streams you wish to enable for your application. Looking at the original Thingy52 sensor stream object, we see that we gave our object a name of Thingy52 sensor. We didn't specify a specific sensor MAC address, so we'll connect to the first Thingy52 we find, and we enabled only the barometric pressure sensor data for broadcasting. Lastly, we specified a new packet event to be queued every time a new packet arrives from the sensor that gets connected through this definition. This, in turn, is the event that triggers the evaluation of the rule we were just looking at. Before we return to our rule definition, we'll point out that in the demonstration configuration file, we enabled Auto Start All Sensors in the System's Options settings so that we didn't need to explicitly connect our sensors in our rule set. Unlike the first rule we looked at, this rule also has associated conditional logic that must be met if the rule's action object is to be executed. In this case, we have two state objects we check and then logically OR. Looking at the first of the two, we see it is a counter value state object which checks the state of our mode counter against a compare value. Specifically, in our example, we're checking if the mode value is equal to 1, in which case we are currently in the mode to send all sensor data. So back to our rule object, and our conditional logic essentially says that if we are currently in mode 1 or in mode 4, we'll execute our action object. Looking at our action object, we see that it is a send data action object, which sends the most recent packet from the selected sensor to the specified IP import. In our example, this was the IP import for the AWS Cloud Server instance we'd configured to run the Omniot packet capture service. That wraps up our Developers Crash Course demonstration video. Hopefully this gives you some insight into the SoftHub's rule engine, how it works, and how easy many IoT applications can be implemented and deployed. Note, however, that this demo only touches on a small fraction of the SoftHub's capabilities. For further information, please check out our SoftHub Introduction and Configuration Guides downloadable from the support page of our website, or the many additional example and how-to videos found on our YouTube channel. Links to both are available in the video description below. Thanks again for watching.